Hello everyone, this is a video for lesson 3-2 for adding, subtracting, and multiplying polynomials. We have two goals for this lesson. Our first goal is to add and subtract polynomials, and the third one is to multiply polynomials and maybe use special product patterns. In this video, we will be using the same techniques that you used in Algebra 1 to add and subtract, and you may do something a little bit newer when you are multiplying. So let's look at adding polynomials. The first thing that you need to pay attention to when adding polynomials is if you have like terms. So like terms are going to have the same variable that are raised to the same power. So you can see right here, you have a 3x and a 4x. You can add those together by adding 3 and 4 to make 7x. But these two over here, the 3x plus 4y, you cannot add them because you don't have the same variable. So likewise with the y squared, you can add 7 plus 5. That's going to give you 12, but these are different variables. Same degree, but different variables. You can't add them together. Then you have 10w and 8w. You can add that to be 18w. The 10t cubed plus 8t cubed, you can add 10 and 8 to make 18t cubed. So you just have to make sure that even if they are the same variable, if you look at this one of them is cubed, the other one is to the power of 5, you are not able to add them together. Now I have an example right here next to it where it says you can add and subtract like terms by combining the coefficient. Remember, that is the number in front of the variable. If it doesn't have a coefficient, it could be a constant. Those are also considered like terms. So as you can see, we have the quadratic terms, and then in green we have the x terms, which are linear, and then we have the constants in pink highlight. And if you add them all together, you wind up with negative 7x squared, negative 4x, minus 4. Now, if you have all of your highlighters out, you can absolutely use this to help you match your like terms, but you don't have to. It's fine. So I'm going to highlight anything that is x to the power of 3 in yellow. And then in blue, I'm going to do the x squared terms. You see how I'm including the negative in front? And then the linear term, I don't have one over here, so I can't do anything with the negative x, but I do have two constants. All right, so that's what I would do if I had a highlighter. If not, I would go ahead and just start writing them down in the order of highest degree. So I have 3x to the third plus 1x cubed. And I'm going to check them when I write them down. And then I have 2x squared minus 10x squared minus x. That's the only linear term. And then I have minus 7 plus 8. So I'm going to have to do these two. That one's all by itself, and then my constant terms. So I have 4x to the third minus 8x squared minus x plus 1. And as long as you are just adding, that is all that you can do. Okay, I have a second example here. If you want to pause the video and go ahead and work it out and just check your answer, that would be perfect. If not, just continue to watch me work it out. I'm going to go ahead and highlight like I did on that first one. I don't have a matching cubic term, but I do have two quadratic terms. Okay, so I'm going to start by writing the 9y to the power of 3. That's the only one. I'm going to write 3y squared minus 5y squared minus 2y plus y plus 1 minus 4. So this one's by itself. These two are quadratic. So 3 minus 5 is negative 2. Negative 2 plus 1 is negative y. And then 1 minus 4 is negative 3. And that's it for addition. So subtraction is where most of our mistakes are made because we are not subtracting everything that should be subtracted. So what you want to do is make sure that you subtract every term from the subtracted polynomial. So if you look at this example right here, it says, I want you to subtract all of these from this polynomial. So when you write it down without using words, you're going to start out with 2z squared plus 3z. And you're supposed to subtract all of these terms right here. That's why it's in parentheses. So when you write it down, and I highly suggest that you always do this step right here, is make sure that you subtract the 3z squared. So that'll be minus 3z squared. Subtract a positive z, that's going to make it minus z, and then minus a negative will change it to positive. So a lot of people, what they'll do is they'll only subtract that first term and they'll completely ignore subtraction for the z and the minus 4, which causes them to miss the problem. So make sure that you continue subtracting all the way throughout, and a lot of people don't want to write it down and they forget when they're doing it in their head, and they miss it. So if you just do one little extra step, take 10 extra seconds, maybe not even 10 seconds, write it down, chances are you'll get it right. Okay, let's do our first example. Now, as you can see, I have no words in here. It just says to subtract all of this right here. So this is the most important step that you do. I'm going to write everything in that first polynomial down. No changes except for I'm going to put a little 1 here in front of the t. Now I'm going to have to subtract everything in yellow. So it's going to be minus 5t to the third power minus a negative. Minus negative becomes plus t squared minus 17. Very important step. Now just add. So we're going to go ahead and match up anything that has like terms. And we will combine like terms now. So this part is very, very important. Please don't skip that step. Okay. So I'm going to add these, that's by itself, and then add those two together. Oops, got ahead of myself. Okay, that is the final answer. All right, on the second example, go ahead and pause that video. Try to write the second step before you watch the rest of the video. If you're really confident, go ahead and finish the problem, and let's see if you get it right. All right, so I'm subtracting everything in parentheses here. So I'm going to very importantly write it down without parentheses. So I'm going to subtract 12p squared, subtract a negative p, which makes that plus a positive. Okay, looks like I only have 2 quadratic terms. So this one and this one right here I can add together. That would be negative 20p squared. This one's next. Plus 7. I did skip a step here. You can if you're feeling good about it. If not, go ahead and write them together using like terms and then finish the problem. Okay, so we're going to switch gears and we're going to talk about multiplication. Multiplication is very different than adding and subtracting. You don't have to worry about like terms. What you're going to do when you multiply likely change the degree, because what happens when you multiply a squared times a to the third power, what your notes show is that this is technically a times a, and this one's a times a times a. So when you write them all together, basically your shortcut is for you to add. So 2 plus a degree of 3 gives you 5. So when you're multiplying, you will be adding the exponents. That is not the case when you're adding and subtracting. So when you add and subtract, you add the coefficient, which is the number in front of your variable. But when you're multiplying, you need to add the exponents. All of my examples today will be using the area model. And the reason why we use the area model is to help you understand polynomial division, because it's going to use the area model, which you already have some experience with anyway. So this one right here basically is asking you to multiply 3x minus 7 times x plus 2. So when you multiply it, you say 3x times x gives you 3x squared. So you're multiplying the row and the column. And at the very end of it, what you do is you add like terms. So you can see that the diagonal is going to give you like terms. So you have 3x squared here. Negative 7 plus 6 gives you negative 1x. And then to finish it out is your constant, which is minus 14. Same thing over here. You are going to multiply this trinomial, didn't mean to mark it out, times this binomial x minus 5. So if you've got 3 terms on the top and you have 2 terms over here, 3 times 2 should give you 6 squares. So you'll have 6 terms. That doesn't mean your answer will have 6 terms, but if you notice, you can add your quadratic terms and you can add your linear terms. So you wind up with a final answer of x to the third, and then add negative 5x squared plus 2x, which gives you negative 3x squared. Add negative 10x and negative 3 to give you negative 13x, and then to finish it out with the constant, which is plus 15. Okay, so let's take a look at our first example. We have 5x minus 2, which has 2 terms in it. We have negative 6x squared plus x, which also has 2 terms. So what I'm going to do is I'm going to create a rectangle or a square that has 2 rows and 2 columns. And it doesn't matter which one you put where, but I'm going to put the yellow one here, and I'm going to put the blue one here. And I'm going to continue that same pattern throughout. So I'm going to write 5x, that's the first term, and then minus 2 here, negative 6x squared, and then I have 1x. All you have to do is multiply row times column. So 5x times negative 6x, it's going to give me negative 30. Now this is a little 1 here, so 1 plus 2 makes 3. So regular multiplication. So 5 times negative 6 is negative 30, but when you're multiplying your variables, you have to add your exponent. Okay, same thing here. I've got 5x to the first times x to the first power will be 5x squared, because you have to add the exponent. Okay, now let's do 12x squared, because negative 6 times negative 2 is 12. And then x times negative 2 is negative 2x. Hopefully you remember all of this stuff from Algebra 1. But the way that your area model works is that typically your diagonal will have like terms in it. So I'm going to start out with negative 30x to the power 3. Add the 12 and 5 to get 17x squared. And then finish it out with minus 2x. And that is your final answer. Okay, next up, a lot of people have missed this. It's kind of like a top 10 most missed question. This is a special product. I'm going to talk about that in a second at the very end of the lesson. But a lot of people will mistakenly say that's going to be 7h squared or 49h squared plus 16. This is incorrect. So you have to multiply this times itself. Same setup. Multiply row and column. Here's where people mess up. They forget that we actually are going to have a middle term here. So this is going to be 49h squared plus 56h plus 16. And like I said before, this is a special product, so if you have the ability to memorize things easily, then maybe you could use a special product instead of using the area model. All right, so this next one is a 3 by 2. So if you want to, you can swap them around and you can write 2x minus 1 first, and then you can do the 3x squared plus x minus 2 second. It does not matter to me. I'm going to go ahead and make 3 rows and 2 columns. So I'm going to do 3x squared plus x minus 2, and on top 2x minus 1. I'm going to change colors on this one. Okay, so just do a quick check. Make sure that you have everything multiplied correctly. See how the diagonals match up with like terms. We have 6x to the power of 3. That's our lead term. And then I have negative 3 plus 2 gives me negative 1x squared. Add these together, negative 5x, and finish it up with a plus 2. So this last example looks something simple. It is not simple. I do need you to be aware that we have 1, 2, 3 polynomials in here. And what you're going to need to do is multiply these two first, and whatever you get for your result from these two, you will multiply it times x minus 6. So I'm going to actually scoot over here, and I'm going to multiply the x minus 5 and then the x plus 2. And I'm going to add these two together right here. And I'm going to write my result underneath. Okay, so when I write this over here, I'm going to put x squared minus 3x minus 10. Now, if I drop this down, this problem looks like I just need to distribute here. This is incorrect. What you want to do is you want to multiply that whole thing, this result, times x minus 6. So now we have a second part to this problem. So I'm going to have a 3 by 2. Okay, so a 3 by 2 over here. I'm going to write x squared minus 3x minus 10. And on the top, I'm going to do x minus 6. Change my colors. Now, the result from this should be my final answer. Okay, like before, we have like terms in here. I'm going to go ahead and add them as I write the answer down. So x to the third, negative 6 minus 3 is negative 9. 18 minus 10 is 8 plus 60. So that is going to be the final answer. I just want to make it look pretty for our notes. And yeah, so if you see anything that has 1, 2, 3 polynomials, make sure you do the first 2, multiply those out, and then multiply by the last polynomial. And the last thing I want to mention is special product patterns. There's really only 2 that I have memorized that I use regularly. If you were in honors, I showed you the square of a binomial. A lot of people forget how to use it. So it's like a plus b squared. So you have the a, that's your first part, and then you have b, that is your second part. You square the first part, you square the second part, but to get your middle term, you multiply them together and you double it. That's where that 2 comes into play. Here's an example here. You do not have to have this memorized. It's just a faster way to do the problem. Making an area model is perfect. You will get the answer correct every time. So don't feel pressured into memorizing this. Same thing with the sum and difference. So if you've got a plus b, a minus b, what's going to happen if you use the area model? That middle term is going to cancel out and you're left with a squared minus b squared. I'm going to be honest with you. I don't remember the sum and the difference of a cube. I've never used it. So like I said before, you don't have to have them memorized. It's just something quick for you. If you have it memorized, use it. That would be great. So I just want to let you know, yes, you do have lots of practice problems here, but you've got a little bit of time in class to work on it, and a lot of it's just adding and simple multiplication. So it shouldn't take you very long to get through it. And as always, please let me know if you've got any questions, and y'all have a great day.